All right, welcome to the next episode of Voice AI podcast, where we discuss the future of voice AI. Today, I'm very excited to host Alan Cowen, who is the CEO and Chief Scientist at Hume AI. Alan, excited to host you.
Great to be here.
Look, as always, I'm going to do like an introduction of Hume AI. This is facilitated by ChatGPT. Let's see how it performs this time. So Hume AI is a startup focused on building emotionally intelligent AI that can understand and respond to human emotions through voice, facial expressions, and language. Founded by former Google researcher, Dr. Alan Cowen, the company combines deep learning with human behavioral science to develop models that interpret emotional cues and optimize for human well-being. Hume's technology is used in applications like customer support, healthcare, and human-computer interaction to make AI more empathetic and effective. I think this was very cool, right? What do you think? Anything I missed? Or
no, I think that's pretty spot on. I would add, maybe there's probably some things that are beyond ChatGPT's knowledge update date or whatever. So last year we were some of the first people to train speech language models. We launched the first speech language model in production called EV, empathic voice interface. I'll talk about why we called it that, why I think that's still the right approach. And we launched a text-to-speech version of that that's more updated, that can represent any voice and any prosody on Earth, pretty much a few weeks ago, and launching something else new soon. The reason that we call it the empathic voice interface is that we believe that AI should be empathic, meaning it acts like something that cares about you. When you're talking to an AI model, its primary objective should be to fulfill your goals, make sure you walk away and feel like you didn't waste your time, and thus optimize for your well-being. Interface in the sense that, we're building models that are not frontier in terms of reasoning. Obviously, like there's only a few companies that can do that. But we're building models that are frontier in terms of understanding the human voice and signs of what your objectives are, getting to know you, generating a voice that you prefer based on your personality. And we believe interface models are separate from the models that are just doing agent-related tasks and separate from workers. So interfaces are talking to users, and they're coordinating agents, which are deep research, scheduling systems, software engineering agents, which are also coordinating workers, which are like deep chain of thought reasoning models that solve math problems and things that draft documents. Those don't need to be empathic, but the interface, the one that's deciding what these things are going to do, should know what the user wants. And so that's been our objective for a while, and that's really what Hume is focused on today.
Yeah, that's super interesting way of framing it. Actually, I've been playing with Hume AI just before the podcast. It's like the voices it generates are very impressive and different, right? Different than what I've seen out there, and I've seen many things. So, and the way you describe it, Ellen, like at least what I understood is like you're saying, you know what, the interface is decoupled from reasoning, and what humans, the reasoning is super important, obviously, because it's like what's gonna do the job, but the interface itself is what user is gonna interact with, and you need a lot of empathy and emotion there, so that users feel good when they use the voice interface. Is that is my understanding correct? And that's the sort of what you're focused on, making the interface amazing.
Yeah, exactly. I mean, it has to be what's different about the model that you're talking to, and I think a lot of it's going to be voice-based because of the fact that while you're speaking, you can also see like a graphical user interface that's being operated at the same time versus the other option being a text box, which distracts visually from what you're doing, and then you have to go back and read responses. So I think voice is really critical here. it has to be empathic. It has to be something you enjoy speaking to. The voice is super important because it's like the whole experience is determined by this voice. And that's really what we've been focusing on. And then it also has to be low latency. So, the way that things are going, there's divergence between the reasoning models, which take a little bit of time to think, and then the low latency model that can be talking to the user at the same time, explaining what's happening, and making sure to be really, really attentive to interruptions and changes of course and changes of goals that can then be relayed to these other models. It has to be super low latency. And the third thing, it has to be able to talk to these other models, which I think a lot of models can do through function calling and through output. So we focus on those capabilities. We've built models that have all of those capabilities. And in the text-to-speech domain, where we launched a product recently, we've been focused on basically being able to optimize as much as possible for users' preferences, what kind of voice they want. So we have a model that can generate any possible voice, and therefore can also optimize for any user and create voices on the fly, which I think is going to be really important because people are going to want a voice that they can trust that's unique to them.
Yeah, actually, this framing is the first time that speech-to-speech models make sense to me. Because look, like the use cases that the speech-to-speech models are being at least promoted in are there is it's confusing. They go into the reasoning space, right? And then when it's in the reasoning space, like why should this whole model have both voice interface and the reasoning in one sort of model and make it complicated? And I never understood why can't we decouple this? And that's where really the interface is where you need the super low latency and emotional understanding, and then you can give the transcript to the reasoning model, right? Is that how it's?
Yeah, you can give the transcript for reasoning models. You can use special tokens to coordinate other models as well. And then you can inject that back in. Say, okay, now we have frontier responses. Web search has been integrated. Frontier reasoning has been integrated. The intelligence of this interface is as high as it can be, but what it's actually using that intelligence for is based on now an understanding of the user's voice, what they're frustrated about, what they're actually confused about, what words they're emphasizing, how their goals change over time on a very on the hundreds of milliseconds level in terms of latency, so it can change course very quickly. That's the kind of responsiveness you need out of what's coordinating all of these bigger AI models, basically.
Interesting.
Yeah, it needs to be speech-to-speech also because transcription, and you can make it there's cascaded systems that are separate transcription, text-to-speech, and language modeling, right? And I think that people have taken that as far as it can go. So they are pretty good at this point, but they've kind of reached a ceiling, right? In order to make them higher quality and faster, you need to make sure there's no redundancy between what these different models are doing, because actually transcription requires language understanding. Then you have separate language understanding. Then you have text-to-speech, which also requires language understanding. And if you're running these models separately, the text-to-speech model doesn't actually know what it's responding to. Or what words to emphasize and what emotions the user is feeling, and it doesn't really understand the context of what it's saying. So having the same source of intelligence handle all three is just a lot better. So I think we're seeing the kind of the ceiling of cascaded approaches being hit, and the speech language model being a better interface overall.
Okay, and it must have some reasoning model as well inside, right? And how much that reasoning model must be, how smart should it be? And right, because the speech language model, it must have some reasoning so that it can keep up the conversation and then sort of offload the more the smarter things to larger reasoning models. Is that correct way of saying it?
That's I mean, it depends on what you mean by reasoning, but yeah, it has to have intelligence, right? It has to have the kind of frontier intelligence that it can possibly have at that latency, which is we've specialized in basically building speech language models that are as smart as the equivalent sized LLM. So we'll always have frontier intelligence. We'll never lose that capability. We're going to provide it at a faster latency than you could even achieve if you hooked up that frontier small LLM to separate text-to-speech and transcription, because those add latency, but we've combined them all into a model. Basically, it doesn't add any latency. Gets all of that done. Frontier intelligence, lower latency. And the reasoning part, so the reason I said it depends on what you mean by reasoning is because then there's a kind of chain of thought process that you don't want this model to do. Chain of thought, actually should be done in parallel. It should be done while the interface model is speaking, because otherwise you're taking away from being able to understand the user in real time. So I think of this as like thinking fast and slow. Like the reason that the brain is organized that way too, right? Where I have like a reasoning module in my brain, and I also can interact with you at the same time, and those can happen in parallel. And that's sort of what needs to happen. I mean, maybe at some point those will all be trained together, but they will be separate autoregressive systems.
Yeah, of course. I mean, by reasoning, I meant like really intelligence.
Yeah.
I think by reasoning, you meant the thinking model, or this chain of thoughts, or like the new stuff.
Mm-hmm.
Okay. That makes sense. So, Alan, like, let's talk about the applications of this, right? And then we can switch to TTS as well. Of course, TTS is a big deal these days. But so, where do you see these speech language models being applied today? I mean, I see a lot of in the conversational AI space. I think the pretty much, I mean, it's fair to say that the cascading sort of approach is the dominant approach today, because like the function calling is more stable there, and then like there's a lot of like more reliability there. But what's your sort of take on this? Like, where are SLMs being deployed already, and where are they winning over the cascading approach?
Yeah, so I think that you're right. I think that there's a lot of enterprises that need to basically have they basically won't be using the frontier models at all. In fact, customer service is still often done without language models at all, surprisingly, but that's most of the time, right? And they're using old school conversational AI systems with traditional text to speech. So if they're not even using language models, like using speech language models is well beyond what they're embracing at this point. So there's going to be some lag, and that's with like the kinds of customer service systems where
you mean like IVR systems?
They're using traditional IVR systems still, of course. Where have language models been embraced? I think that's like they're kind of, I guess there's a separate aspect to this question. It's like where are people embracing speech language models? Where are people embracing cascaded systems with language models? And then there's the old systems. The old systems are still dominant, there's no doubt, but I think they're going to be replaced very soon. The systems that have cascaded language model, text-to-speech transcription, those became the dominant approach for deploying language models before you had stable speech-language models. And I don't think that speech-language models, I think you're right, they're just reaching the point where they're stable enough to be deployed in similar contexts. But I think this year is the shift, right? from the cascaded systems to speech-language models. We're already seeing in more ambitious applications that people prefer speech-language models when, for example, it's a character, like a avatar NPC kind of setting, or for anything where you need higher quality voice, because the speech language models produce higher quality voice, which is why we've actually launched a text-to-speech system in our most recent speech language model before even putting that into production as an interactive system, is that the voice quality is really important in a wide variety of applications. And so you reach a certain ceiling with text-to-speech, but at a certain point it doesn't really understand what it's saying because it hasn't been trained on like the trillions of tokens that language models see. So we're deploying systems, and the kinds of people who need that, people making audiobooks where the narration has to be really high quality, people making voiceover content for social media or advertising. So we're seeing, we're pretty rapidly seeing a lot of people adopting our text-to-speech system, even though it's new, and there's still some, we had to fix some things, but people were desperate enough to ask us to, like, we really need this, please fix this. So, so there's that. And then, by the end of the year, I think we'll have systems that for better or for worse, are indistinguishable from humans during interaction, which will be a relatively new thing. So like passing the speech Turing test. And those will be speech language model based. Cascaded systems get to a ceiling and they can't get to that level, but speech language models can. And that's this year. So the ceiling is being raised very rapidly. Once we have,
is there such a test, like passing a Turing test for language?
Yeah, we have that internally, but I don't think there's like a public eval. But
okay.
Yeah, if you you can run like basically, there's a few different ways to do it. You can actually have someone talking to a human versus talking to the AI.
Yeah.
Compare different AIs. We run a bunch of psychological tests, basically. That's a big part of what our company does.
Interesting. Very cool. And do you see that do you see that being important for customer service? Let's say the language sort of quality, right? I mean the speech quality itself. I'm just curious about your thoughts, because like you could think, you might think that it might. I mean, like as long as it does the job and it is able to communicate customers. I mean, like there is a point where, of course, empathy and how you deliver this is going to be important, but that's not the majority case from what I can imagine, right?
So I think customer service traditionally, and this is maybe not a good thing. I think traditionally has been pretty separate from product, and kind of and the objectives have not really been like, let's make the user experience as good as possible. A lot of the time, the objective for large enterprises with customer service is to get somebody off the phone and to like reduce cost as much as possible. And it's just something they have to have. But historically, people haven't expected to be able to talk to somebody as part of the core product experience. And so they don't really make buying decisions based on who has the best customer service. This is changing, right? Because a lot of products are integrating voice directly. And what was once a separate customer service experience for like a banking app, now they're doing it in the app. And they're saying, hey, I can't figure out how to send this person money. Like, can you do this for me? Now it's a core part of the product experience because it's in the app. It's better than traditional customer service in a lot of ways. It has all of the context. It knows what you're trying to do. It has your account information. You don't need to provide it. And it can figure out, based on all of the actions that you've taken, what you're not doing right or what it's not doing right. And it can diagnose all of this on its own in a fraction of a second versus a human who would need to like be thinking about this and looking up your information and trying to, and investigating a problem. Now that's going to be, because that's part of the product, what you're optimizing for is different. So I think there's been a lot of success in deploying systems so far that are really cheap, right? And there's kind of been a race to the bottom of that in the traditional customer service context. And I think that's going to remain true in the traditional customer service context, where the company doesn't actually care if it's a good experience or not. But I think that people's expectations are going to rise over time for what customer service really looks like and what the experience should be.
Yeah, this is, again, like very refreshing way of framing it. I love it, actually. Like, I can imagine, products that care about experience and design, they would be so, so like they would care about the details of this interaction as well, right? And they would even like go as far as picking what like brand it should, the voice must be branded, right? Or be own brand, or the conversation must be own brand within the product itself. Like, this is very interesting. Cool. look, let's switch the gear to TTS, right? Text to speech model that you just launched, I guess. Okay, and is like, how does it compare to the industry, right? I guess like 11 Labs is the leading provider today, with again, like, I need to complain, with very high prices. But what I see in the industry is that there are new, like, emerging players who compete with 11 Labs on different fronts, like latency. Like, okay, this one is, I guess, like Artesia or Rhyme. They are optimized for conversational AI, and there are some that are competing on the quality side. Some on the, like, number of languages supported. Like, how should we think about Hume's TTS? Like, where does it excel?
Yeah. So our text to speech, since it's based on a speech language model, sounds a lot more natural. So if you care about that, that's where we really excel. You can also design voices with just a prompt, and you can give it acting instructions to change how the voice sounds. All of that is because it's a language model that has a deep understanding of what those instructions actually mean. So if you care about creating characters, if you care about personality, if you care about emotional expression, we're excellent at those things. We also have been improving our audio quality since launch, and now in head-to-head ratings against 11 Labs, we significantly beat them on both quality and naturalness.
Okay.
We from launch, we had that with voice design, so they have voice design as well. We also have our own voice creation, which is within the actual model itself. We beat them on that at launch. Now we're beating them on continuation with any speaker. I think for 11 Labs, like, since it's all voice clones, they have some really good speakers. And so we've set the standard for ourselves of we should beat those their best voices. And now we're starting to do that. We'll be releasing evals soon to prove that we do that. So I think we're also cheaper. So I think hopefully we beat them on most fronts. They have us on languages.
What about, like, languages?
Yeah.
They what?
They have more languages than us, and we're working on that too. Yeah.
Okay. And what languages do you guys support today?
Today we have English and Spanish, although Spanish is not as good. But in the next few weeks, we'll hopefully be adding more. I can't say exactly which ones, but at least 5 different languages.
Yeah. Oh, nice. And is it possible, like, given that it's prompt based, right? Is it possible to instruct it to, like, I don't know, spell certain things, like, be more careful when you spell, let's say, credit card numbers and like, I don't know, address, because we have seen, like, other models struggling with this.
Yeah. Since our model is a speech language model, it's actually better at understanding unique kinds of inputs. Still improving. But if it really is not able to pronounce something, you can also put in phonemes in IPA format, and it can pronounce them that way. We can also automate that. Like, you can ask Claude for the phonemes basically, and then you can copy paste them in. We should just have that embedded in our product, but we've got a lot to do. So yeah.
Okay. Yeah, this is amazing. Congrats with the launch.
Thank you.
Yeah, we will take a look at, because we're building a product that is using TTS. This is the first time for us, so like, we are struggling with different ones today as we speak, actually.
Yeah,
cool.
And then one thing I didn't mention is latency. So when we launched not real time, but we're going to be releasing a real time API very shortly, maybe before people hear this. So that will be very fast. Yeah.
Nice. Yeah, we need that. Okay. Very cool. And lastly, Alan, I wanted to talk about you have this emotion expression measurement API, right? If you can also, like, share what it is and how we should be thinking about it. It seems to be quite unique.
Yeah. So when we started Hume, that was the focus, is we wanted to first measure expressive behavior really accurately across many cultures, demographics, and so forth, and be able to give you those measurements, which we began integrating into language models pretty shortly after. So our goal was, let's give language models this understanding of multimodal behavior. Since then, we have speech language models, obviously, that have really, like, exploded in the last year. We launched the first one, then GPT-4o voice, and other companies. Well, that's basically it. Gemini maybe is to some extent a speech language model as well. But that's where we're really focused. And the expression measurement data, that all has, we collect data at a large scale from around the world to train those models. We use that data to train our text-to-speech, speech LLMs. It goes to everything. So the understanding of expression that we derive from all of that really rigorously controlled scientific data that's at an unprecedented scale, that's improving all of our models across the board now.
So given audio, and I know there is video as well, but let's focus on voice. So given audio, you return the expressiveness, different characteristics of voice, so that like developers can use it in their apps. Is that like the way we should be thinking about it?
Yeah. So people recognize at least 24 different dimensions of emotion that's expressed in the voice, and at least 28 dimensions in facial expression. That's something that I found in my research. I have a PhD in psychology, and like early on, back when I started in 2013, nobody was really working at the intersection of these two worlds, and then that work led to the creation of the affective computing team at Google, and that's where I worked for a few years, and then started Hume. And so that's the core of it, was really being able to label all of the different dimensions of expression that people understand in the right level of nuance, which is a big leap forward from traditional approaches, which focused on either the 6 basic emotions or valence and arousal, which the early work showed for the first time that these captured less than 20% of what people actually perceive in expression. So a big barrier early on was getting past that. Now we provide that through our expression measurement API, which is used in a lot of different kinds of settings. Like, for example, in clinical settings, you can predict progression of depression symptoms with our facial expression measurements. But the voice part of that, the prosody, meaning the different dimensions of expression in speech, as well as vocal bursts, laugh, sigh, screams, etc., all of that is also built into our generative models. So that gives them the amount of nuance that they have, and our empathic voice interface product uses that to train the way that it is perceiving users' voice as well. So it can perceive user voice in all of these dimensions and respond appropriately. And that's kind of happening in its latent space at this point. But the data that is used to train those models is in there.
Very cool.
Yeah.
Very impressive stuff. Well, Ellen, thanks so much for coming and sharing all these amazing products that you guys have, and your insights as well.
Thanks. Yeah, thanks for having me. It was a pleasure.